Welcome. Allow me take you through chemistry paper 3, practical of the one which was done by the group that went this year on March 2022. So this is the paper they did. It is from NEC. This is the paper they did. So let us go straight inside and let us see what we were supposed to do. So let us look at what you are provided with. So the students of that time, that is on March, they were provided with 0.1 molar solution of a monobasic acid A. So once you have had a monobasic, let me give you an example of a monobasic acid. HCl is an example of a monobasic acid. Nitric acid is an example of a monobasic acid. So that is it. And then they were provided with solution B, which was sodium hydroxide solution. Solution C, which contained 10 grams of acid C per liter of solution. So what I get from here is that this is 10 grams in 1 liter of solution C. We don't know anything about solution B. So what are you required to do? So the students were required to standardize solution B using solution A, and then determine the number of moles of sodium hydroxide that react with 1 mole of acid C. Procedure. Fill the purette with solution A using a pipette and a pipette filler. Place 25 of solution B into a 250 ml conical flask. Titrate solution B with solution A using phenolphthalein indicator and record your results in the values of the table. Let us use 25.0, 24.9, and then 25.1. So our initial is 0.0, 0.0, 0.0, which will give us 25.1, 24.9, and then 25.0. So let us do our average. Our average is that is 25 plus 24.9 plus 25.1 divided by 3, which will give us 25.0 centimeters cube. Yes. Welcome. That 0.10 capital M B, solution B, this is the number of moles. This implies that 0.10 is the number of moles in 1 liter centimeters cube. 1 liter is 1,000 centimeters cube. So if this is the number of moles in 1,000 centimeters cube, what will be the number of moles in 25 centimeters cube of solution A? Solution A. So we ask 25 centimeters cube would give us what? So it is 25 times 0.1 divided by 1,000, which would give us the number of moles in 25 centimeters cube of solution A, which is equal to 0.0025 moles. So let us go to the next. The other side of the paper. Calculate the number of moles of sodium hydroxide N in 25 centimeters cube of solution B. So this is something that made students to be confused a lot. So they were wondering what is N. But the question is asking calculate the number of moles of sodium hydroxide in 25 centimeters cubes of solution B. So N represents the number of moles in 25. So N is just the number of moles in 25 centimeters cube of solution B. But this letter N here gives students a lot of headache, and they could not understand where N came from. Others even called me during the experiment, and they were asking whether this was a mistake or a misplaced letter. But since we don't speak, we just keep quiet. So we know, then for us to get, we know the monobasic acid will react with the sodium hydroxide, and the ratio to the mole ratio, the mole ratio equal to 1 to 1. So if this is the acid, the monobasic, and then the sodium hydroxide, the ratio is going to be 1 to 1. Why? Because it's an acid like sodium hydroxide reacting with HCl. This one is it will give you sodium hydroxide chloride plus water. So this one is, the ratio is 1 to 1. That's why we are saying that this is a monobasic acid. So this is an example of a monobasic acid. Therefore, it means that the number of moles that we have calculated in Roman 2, because the ratio of A and B is 1 to 1, therefore the number of moles of B25 solution B will be equal to this number of moles, because the ratio is 1 to 1. So since the ratio is 1 to 1, moles of 25 centimeters cube solution B equal to 0.0025 moles. The ratio is 1 to 1, therefore the number of, so this number of moles we have gotten here is what was referred as N. Now calculated the number of moles of sodium hydroxide. That is that number of moles. This one is N. So that was the confusion. But number Roman 4 is that calculate the concentration of sodium hydroxide in moles per liter. Moles per liter. Moles per liter simply means calculate molality. It means calculate molality. Molality is the number of moles in 1,000 centimeters cube, because 1,000 centimeters cube is 1 liter. So we already have the number of moles in 25 here. Number of moles in 25 solution B, which is sodium hydroxide, is here. So we say if 0.0025 is the number of moles which are in 25 centimeters cube solution B, and the B is sodium hydroxide, what will be the number of moles in 1 liter? 1,000 centimeters cube will contain how many moles? Because molality, concentration in moles per liter is actually molality. So this times this divided by this. So that one, the 1,000 times 0.0025 divided by 25. This one simply gives you 0.1. Capital M represents molality. But the good thing is that when you don't know the units to use in paper 3, you don't have to write. You can just leave your answer 0.1 and you will score all your marks. Don't write any units that you are not sure of. If you don't know, you are supposed to write moles. If you don't know, you are supposed to write capital M representing molality. Don't write anything, just write your answer and stop at that point. Let us go to procedure 2. Clean the puree and fill it with solution C using a pipette and a pipette filler. Place 25 centimeters cube of solution B into a 250 ml conical flask. Titrate solution B with solution C using a phenolphthalein indicator and then record the observation. So the recorded value was 16.5. That was the correct value, 16.6 and 16.5, and then the initial, take it to be 0.0. This one will give us 16.5, 16.6, and then sorry, one is supposed to be 16.4. Let us use this one, 16.4. So our average now, average will be 16.5 plus 16.6 plus 16.4, and then divided by 3. This one will give us 49.5 divided by 3, and the answer is 16.5. For example, here you don't know whether you're supposed to write centimeters cube, but when they ask the average volume, always the volume is measured in cubic centimeters. Therefore, you know. If you don't know, just leave it like that instead of writing things that you don't know. But since you are a good student, just write centimeters cube. Yes, so we want to, the question is asking calculate the concentration in moles per liter of solution C, given that the relative formula mass of acid C is 210. So we have this is relative formula mass is RFM, is the RFM. So, but remember from we were given that, I want to show you what we are supposed to know. Solution C, how was solution C prepared? It contains 10 grams in 1 liter. So we have mass in grams per liter of solution C already. Therefore, that one is it becomes easy on how to handle this one. Therefore, here I will give you this triangle. Here write molarity. Here we have mass in grams per liter, and here we have RFM. Concentration in moles per liter means molarity. Grams per liter. So long as it is the number of moles in 1 liter, that is concentration, then it is molarity. So the question is asking how to calculate the molarity. Say for molarity, how do you get molarity? Molarity equal to mass in grams per liter divided by RFM. RFM is here. The mass that was dissolved to form solution C was 10 grams per liter, and then RFM it is 210 to 10. Now this one gives you 0.04 0.0476. This is the number, this is the molarity. Therefore, you can leave it like that or put capital M. Capital M stands for molarity. So calculate the number of moles of acid C in the average volume used. Now we have the molarity of solution C. Molarity, which is the number of moles in 1 liter in 1,000 centimeters cube. We used 16.5. Yeah, our average, you can see here, our average was 16.5. Our average here is 16.5 of solution C used. So we ask that 1,000 centimeters cube of solution C contains 0.0476 moles. What will 16.5 centimeters cube of solution C contain? So this times C divided by this, that will give you 0.00076.5. That is the number of moles that were in 16.5 centimeters cube solution C. Write the ratio of moles of C to moles of sodium hydroxide N in 25 centimeters of solution B. So C, this is writing the moles of solution of the acid. This acid, now write the ratio of moles of acid C to moles. So this is the number of moles of acid C. And the moles are this. So we are going to write the ratio of C to B. But the number of moles in B, we have it from here. Because we are using moles N, moles N. And this is moles N. This is our moles N. Our moles N is here, 0.0025. So that we are just writing the ratio. So this one is 0.00 because it is this one, 0.7652, 0.0025. That was just writing the ratio. Determine the number of moles of sodium hydroxide that react with 1 mole of acid C. So we know acid C, this is the ratio we have, C to B. And the number of moles we have said is 0.000765 to 0.0025. But the question is asking us, determine the number of moles of sodium hydroxide, so solution B sodium hydroxide, that react with 1 mole of acid C. So how can we make this one mole? We divide it by 0.00765 so that this one will become 1. And then divide by here the same number, 0.00765. So this one cancels out and we get here 1, 2. Divided by this and this, you get 3 point some numbers here. Because it is a ratio, we give it our number. Therefore, 1 mole of acid C react with 3 moles of sodium hydroxide. Therefore, the answer is 3. The answer is 3. I want to take you to qualitative analysis. Allow me to jump this graph. And then I'm taking back you to qualitative analysis. I will take you to qualitative analysis. You are provided with solid A. Carry out the following tests and record your observations and inferences in the spaces provided. Place all the solid E in a boring tube. Add about 10 centimeters cube of dilute nitric acid. Warm the mixture and then allow it to stand until all the solid dissolves. Add about 10 centimeters cube of distilled water to the solution and shake. Retain the solution for test B and C. So we are adding dilute. You are adding dilute nitric acid to salt E that you don't know. So we expect that the salt could be something like a carbonate. So we expect to see effervescence because we are adding an acid. That is the expectation, that we will see effervescence or you will not see effervescence. So whenever you are adding an acid to a given solid, you are adding an acid, just expect effervescence. If there is no effervescence, then it means there is no carbonate inside there or sulfite. So for this one, the observation was that there is no effervescence. So if there is no effervescence, it means that the carbonate, the sulfite, is absent. If there was effervescence, then the carbonate and the sulfite is present. That is the observation number 1 for adding the acid. And after that, you are supposed to add water what happened? Did the solid dissolve to form a colorless solution, or which color? What was the color after dissolving in water? So for this one, that is another observation you need to make. Solid E dissolves to form a blue solution. So E dissolves to form a blue solution. Once a blue solution is formed, don't think twice. That one simply means the copper 2 ions are present. That's what it means. Use about 2 centimeters portion of solution obtained in 3A for each of the following tests. To the first portion, add 2 to 3 drops of aqueous barium nitrate. We are adding barium nitrate. Remember, we have talked about barium nitrate. We expect a white precipitate or no white precipitate. So for this case, there was no white PPT. No white PPT formed. You can say formed. No white PPT formed. So if there was no white PPT formed, then it means there was no carbonate, there was no sulfite. Of course, to make a we have said that these ones were absent. So here now, what we are remained with, we are going to say that there is no sulfate. This one is absent. The sulfate ion is absent, right? Because now we are not going to again write the carbonate or the sulfite here that it is absent. Already we have said up here that it is not there. Therefore, we write this one is absent. That shows maturity and understanding of the concepts. To the second portion, add 2 or 3 drops of aqueous lead nitrate. We are adding lead nitrate. Now remember, from here we have said there is no carbonate, there is no, so let us see the observation here. When we added lead nitrate, when you are adding lead, remember, you expect a white precipitate or a yellow precipitate. Like I said on the other video, lead iodide, if there was iodine inside there, it will form lead iodide, which is a yellow precipitate. If there is a chloride inside there, it will form lead chloride. So let us see the observation. No yellow PPT formed. So if there is no yellow PPT formed, it means that the iodine ions was absent. No white PPT formed. Now, if there is no white PPT formed, then we say there is no chloride ion. Chloride ions was absent. Sometimes you can even say bromide ion, because bromide ions also formed a white precipitate with lead. Absent. These 2 ions were absent. Now the question is, why didn't I say the sulfate, the sulfite, and the carbonate? It is because already from the above experiments, we have already said that the carbonate, the sulfite, and the sulfate are not there. Therefore, we are not going to repeat ourselves. We only include the anion or the cation that we have not mentioned. Therefore, this means this chloride is absent. To the third portion, add aqueous sodium hydroxide dropwise until in excess. We are adding sodium hydroxide until in excess. Sodium hydroxide until in excess. The blue PPT for blue PPT is formed, which does not dissolve or insoluble in excess. So a blue precipitate is formed which does not dissolve in excess sodium hydroxide. Therefore, that confirms that also tells you that it is the 2 copper 2 ions are are present. So long as it is a blue precipitate, it confirms copper. Copper 2 ions are the only ions which are blue in color. Place about 3 centimeters of aqueous ammonia in a test tube. To the fourth portion, add all the aqueous ammonia from the test tube dropwise. Place 3 centimeters of aqueous ammonia in a test tube. To the fourth portion, add all aqueous ammonia from the test tube dropwise. So dropwise. So if you are putting drop or you are adding dropwise, don't expect them to tell you until in excess. Dropwise, you put it dropwise and then you end in excess. That is the expectation of you. So here, a blue precipitate, a blue PPT is formed. It starts to dissolve in excess to form a deep blue solution. A deep blue solution. That tells you it is copper 2 ions that are present. So when you find things repeating themselves like this, don't worry, you are very fine. You are just doing the right thing. To the remaining solution of solid E in the boiling tube, add all solid G provided. Shake the mixture for about 2 minutes, after the mixture, filter the mixture into a boiling tube. Retain the filtrate for tests 1 and Roman 2. So a blue solution. Remember the blue solution, solid E formed a blue solution. Now the blue solution, the observation is that the blue solution changes to green. So if the blue solution changes to green, it means that the copper ions has been displaced. Displaced by what? What is green? The green is the ion 2. Therefore, it means that copper 2 has displaced. It's been displaced by G. Then a brown residue is formed, or remains brown residue. Then another thing is that after filtration, we have a green filtrate. And then you also can add that Cu2 positive reduced by G. To about 2 centimeters portion of filtrate, add aqueous ammonia dropwise until in excess. You are adding aqueous ammonia, that is sodium hydroxide, dropwise until in excess. Then green PPT is formed, which is insoluble in excess. That one is ion 2 present. Ion 2 is present. To about 2 centimeters portion of the filtrate, add 2 to 3 drops of dilute hydrogen peroxide solution. So green solution changes to brown. So green solution changes to brown. So that means ion 2 has been oxidized to ion 3, because ion 3 are the one which are brown. So you can say ion 3 formed. Ion 3 formed. And here you expect a vapor sense. Here you don't have to put anything there. This is the last printed page. And remember, this is the KCSE Certificate of Secondary Education 2021, which was done in 2022 on March. It was March. Thank you for your time. May you be blessed.